This is log page 3 on the transformation of functions. What we're going to learn in this PowerPoint is the vertical and horizontal shifts and how to use them to sketch graphs. The stretches and compressions, they'll be vertical and horizontal as well, to sketch graphs, and reflections to sketch graphs of functions. This first video is going to be the objective using vertical and horizontal shifts to sketch functions of graphs. Alright, so let's look at shifting graphs. If I have a function h of x equals x squared plus 2, the first thing that I'm going to do is start with the parent function, which in this case is the square function or the quadratic function f of x equals x squared. And you can see the picture of it here. It has the point 0, 0, 1, 1, and negative 1, 1. Those are the critical points. We're going to take this graph and shift it up to give us the graph of x squared plus 2. X squared plus 2 can in general form be written f of x plus 2. This just means right here that I can put any function in here at all from my library. It doesn't have to be the square function. It could be the cube function or the square root function or the absolute value function or the reciprocal function. Any of the functions from my library. Notice that this 2 is being added on the outside of the function. After the function has been applied, we're adding the 2. So the 2 is on the outside of the function, which equals a vertical shift, and since the 2 is positive, we're going to shift up 2 units. Let's look at h of x equals x squared minus 3. We're going to start with f of x equals x squared again, our parabola. We're going to shift this one down 3 units because of the negative 3. Notice that the critical point 0, 0 shifts down to 0, negative 3. So everything is shifting down 3 units because we have the negative 3 on the outside. So h of x equals x squared minus 3. If you want to write this in general form, it would be any function f of x minus 3. Since we have a negative 3 being added on the outside of the function, it's going to be a vertical shift. Outside the function affects the function vertically, and this is going to shift down 3 units. Let me go back to that just for a minute so that I can tell you one other thing. Please be aware that when we are working on the outside of the function with this negative 3 or like the previous one, positive 2, that the y coordinate is the one that is always going to be affected. So 0, 0 becomes 0, negative 3. The x value stays the same and the y value changes by a negative 3. What happens then when I put a number on the inside of the function? Well, we're still going to start here with the parent function, which in this case is the parabola f of x equals x squared. But this time, because this 2 is inside the function, so it's being subtracted before the function is applied, this is going to shift to the right 2 units. Now, most of the time when we look at this, we would think minus 2 should go to the left 2 units. But this is always going to do the opposite of what we think. If it's inside the function, it's going to do opposite of what we think. To write this in general, we're going to say f, that's the function, of x minus 2. The minus 2 is on the inside of the function. So inside the function is the same as a horizontal shift, in this case to the right 2 units. The x value is what is going to be affected here. Look at this graph, 0, 0, this is 3, 0. So the x of 0 changed to a 3 and the y of 0 stayed 0. Notice that it is different than what we might think. We might think that x minus 2 should shift to the left, but it really doesn't. It shifts to the right. And that's because the minus sign is part of the formula. So this is x minus 2, and we're subtracting a positive 2, so it's going to the right. If we have h of x equals x plus 3 squared, that quantity squared, then the plus 3 is on the inside of the function. Well, inside the function does opposite of what we think, so this is going to be a shift 3 units to the left, starting with the original function and shifting 3 units to the left. Again, my x value of each point is what's affected. 0, 0 changes to negative 3, 0. And the reason this is because I could write this as x minus negative 3. Minus negative 3. Negative 3 would mean shift to the left. Okay, here it is in general form. F of x plus 3. That x plus 3 is now the argument, or the inside of the function. Inside the function is equal to a horizontal shift left 3 units. Notice that this is opposite of what we might think. We might think that x plus 3, that quantity squared, would go to the right 3 units, but it doesn't. It goes to the left. Okay, vertical and horizontal shifts. Here's your summary. If c is a positive real number, the vertical and horizontal shifts of the graph of y equals f of x are represented this way. Outside the function is always going to be a vertical change. Outside, vertical. Vertical shift c units upward if I have f of x plus c. A vertical shift c units downward if I have f of x minus c. If I'm inside the function, it's going to be a horizontal change. If it's f of x minus c, that's going to be a shift c units to the right. If I have h of x equals x, f of x plus c, that's going to be a horizontal shift c units to the left. Notice that these are opposite. X minus c goes to the right, x plus c goes to the left. Notice that these are exactly what we would expect. F of x plus c goes c units up. F of x minus c goes c units downward. Okay, let's look at an example. Okay, we're going to use f of x equals x cubed to sketch the graph of each function. So here's x cubed minus 1 for g of x. This is outside the function, so I would expect this to go down 1 unit. This one, x plus 2 on the inside of the function, I would expect this to go left 2, and plus 1 on the outside, I would expect it to go up 1. Okay, so let's look at it. G of x equals x cubed minus 1. Okay, so this is the parent function, f of x equals x cubed. The graph of g of x equals x cubed minus 1 will go down 1 unit. I'm sorry, I went too fast there. It will go down 1 unit because it's just minus 1. Okay, the h of x equals x plus 2, that quantity cubed, plus 1. Okay, it's still the x cubed function. Okay, it's going to go left 2 units and up 1 unit.